what would you do if I just didn't complete this? So in your head, you completed my sentence, right? You probably said sentence or statement, something in your head completed what I was going to say. And that's basically how generative AI actually works, is that it really learns to sort of complete the next most likely word by word at a time.
Concept of generative AI, I would say the difference between a traditional AI model and a generative AI model is that the traditional model is built to perform a particular task. So you build a classification model to really address a classification task. So it's very, I would say, vertically kind of like developed. But if you want to do several things at the same time, so if you want to summarize and you want to extract the sentiment of a conversation or a body of text, and you want to generate an email out of that, then generative AI models are better suited for that. So generative AI models have been built on a large corpus of data, and they have trained themselves to actually perform multiple tasks at high capacity. So they can do a lot of different tasks, like as I said, content generation, summarization. They can generate code from natural language. They can do knowledge mining. So they can be much more powerful than the traditional ones. But also another thing to keep in mind is that not all use cases should be addressed through these generative AI models. I think that's a common misconception, that they're so powerful and they can solve every use case that we have, which is not the case. I think we have to start with what are we solving for, what is the scenario that we really want to optimize or automate, and then pick the right AI model for the task.
A foundation model is a large model that has been trained not just to perform a very specific task, but rather it has been kind of built so that it's the foundational element, the key building block for many tasks that it can be applied to. So we see them today with models like GPT, where the model itself, it's while there are some objectives we use to actually train the model, the nature of the model is such that the task used for training is not that important from the usage standpoint. These models then get used for things like summarization or classification or content generation. And in the end, they're the same underlying model. Sometimes they're fine-tuned, sometimes not even that. They're just kind of few-shot prompted. So I think, I think the industry kind of looked for a term for a while. We sometimes hear large language models, sometimes we hear foundational models. These things will go into, they'll go past text. They're already going past text. So we need a name. Maybe large language models was good at some point, but maybe we need a new name. And it's been a while since foundational models, and a write-up that went with that went out, and it may be the name to use.
There's a guy named Andre Karpathy, and he used to run AI at Tesla, and he does something else now, but he said something that kind of stuck with me. He said, the hottest new programming language is English. And so the way that you program these things like GPT is by using natural language like English. It doesn't have to be English, it can be other languages, but it's not a programming language as you normally think of it. So prompt engineering is the art of using this kind of natural language to get the results you're looking for from the model.
Turns out that when we all first get in touch with these models, we try the simple things, complete the sentence, summarize this text, and they all look reasonable. But as the tasks get more complicated, or as the input gets more open-ended, you want to make sure that you give proper instruction to the model. Sometimes you want to also enforce certain formats of inputs or outputs, or a certain interaction style. And prompt engineering is this whole practice of how do you construct these prompts, what are the sort of tools and patterns available to you in order to get the system or the model to do what you want, and also how to then, when you have a starting point of a prompt, how to then go from there into what is the right way to iterate and maybe even sweep over like a set of slightly different prompts, validate which ones are doing better, and then once you shipped, maybe one iteration of the app with this, then how do you know that the next iteration doesn't regress? So all of that has to do with, in the past we would have done that with code and unit tests. I guess we're in a new world, and now some of these things you need to explain to the thing in English, and there is a structure that needs to kind of emerge around this, and I think prompt engineering covers that kind of overall problem space.
Imagine for a second that you're trying to learn something new. Maybe you are in elementary school or high school. There's a new concept you are struggling with, and there's something that can help you on the way. You can ask questions. It can explain things to you. This is the opportunity we have in our hands. The other beautiful opportunity in the education system is that all of these we call co-pilots, these assistive agents, can personalize to you, can learn about how you learn. We all recognize that there are differences in the way we learn, and now these agents can personalize these experiences to us. That's what is so exciting about them.
I really think that generative AI has the potential to support knowledge workers, information workers, to deliver that first rough draft of something, to get us, and I really am thinking of how it helps me in my work in being able to deliver and get me unstuck sometimes when I'm trying to figure out how to get started.
In the context of business landscape, all these large language models are going to push on both of the fronts you would look for. First, for things we already do. It'll make us faster, more effective, more productive on accomplishing what we need to accomplish on tasks that we already understand. But it will also let us go for things that we maybe would have not tackled today. So I think we can be curious about going and searching for things that maybe as a business we wish we could do, but maybe we didn't have the right tools in the past. And I fully expect a whole bunch of disruption emerging out of these tools being broadly available for businesses to go use and put to work on their own problem domains.
The reality is that yes, AI might replace some jobs that they were probably low-paying jobs, they were repetitive jobs, they were jobs that didn't really require any critical thinking or complicated tasks that a human brain does. But at the same time, we're going to see the proliferation of net new jobs that require knowledge of AI across multiple industries. So, for example, in healthcare, it's going to be really a great tool for a physician or a radiologist that they want to really interpret an X-ray, or it will be a great tool for someone in manufacturing that want to expedite kind of like repetitive tasks. It will be also a great way for educators to really create more personalized lesson plans for their students.
Where it's going to start is in search engines like Bing. So certainly that has taken off in a big way. And in assistive coding environments like GitHub Copilot. And so already you see these kinds of large language models taking off there. I think we're going to see them more and more in all kinds of other software applications that we use today. And so here at Microsoft, of course, you're going to see it in things like Teams and Dynamics and Office. And it's going to show up in all of these different places to kind of help you do what you do. So I think that's going to be a thing. Over the longer term, I think it's going to start to show up in the real world. I think that we're going to start to see assistive technologies that can actually take actions for us, that they'll start to be able to first order a pizza for us, and then maybe later on they'll be able to clean up a spill if you spill your Coke on the floor or something like that. So that's coming.
We see AI being a great tool to automate a lot of the tasks. We see that also with the retail space, the idea of further personalizing the experience of a shopper. And in healthcare, it's a great way, again, to personalize health kind of like scenarios, and also give physicians and healthcare providers greater tools so that they can do their work better, faster, easier, and more accurately. And in general, I think AI tools can really provide, automate a lot of mundane tasks and allow humans to actually spend more time doing what they're great doing, which requires a lot of critical thinking, creativity, so ultimately increasing the productivity of these individuals.
If I make an image with something like DALL-E or Stable Diffusion that is an Andy Warhol painting that never existed, who owns the copyright to that? Do I own it? Does Andy Warhol own it? Because he didn't make that either.
It is very clear that a lot of power of these models come from the data that they are trained in. As Microsoft, we are careful about where this data comes from and be able to track the source of the data that we are using. At the same time, we also recognize that as generative AI becomes more and more powerful, we will need to think about new set of rules and regulations that can really govern our relationship with data. This is why some of these problems have to be an industry size discussions, and then we have to engage with other companies and lawmakers and the NGOs to be able to make the right decisions when it comes to data and our use of the data.
I think that the future of this AI technology, the importance of this next generation of AI, generative AI, is really important to consider the potential for the benefits and also think about how we can safeguard and protect people, organizations, and society from the potential ways it could be misused. That's really important and part of what I'm so proud of the work that Microsoft does in this space.
Responsible AI is at the core of how we build AI systems in this company and also how we deploy them. Microsoft has been a leader in the responsible AI space from the beginning. We have a whole ecosystem in this company, including the work I and my colleagues do in the research space, to the product teams that we work with, and also the legal teams we work with that support our work. And it is very important to be principled in our approach to responsible AI. So the way we approach this problem is that from the design stages of the AI systems we build, we think about responsible AI. We think about our responsible AI principles. We think about the potential impact of our systems on the world. And then we follow careful processes in place with our responsible AI standard to think about measurement and mitigation. At the same time, we recognize that all of the issues we are facing in the responsible AI space, it will be an ongoing process. We will be learning from deploying these systems into the world and observe the impact they are creating, and then revise our mitigations and continuously work towards creating applications and processes that can do this better and better.
I guess I have two answers to what's next for generative AI. The first one, who knows? I mean, at the speed this is happening, I think if we've shown one thing is that this kind of much faster than linear progress that we're seeing doesn't seem to be stopping. But maybe a more concrete point on this is, I think we'll see applicability. For now, I think we're in the kind of fascination stage where early adopters are starting to apply it, but in the more broader sense, we're still all trying to figure out what's the best way to put this technology to work and what are the best scenarios, both existing and new, where this can play a role. I think while there will continue to be progress, of course, on the bleeding edge, I think applicability of this technology is going to be a fascinating space. We'll see all these creative ideas materializing on real new types of applications.